maybe there are things alien life could be doing that is happening near us or around us and we're not seeing it.
Do you think there's life on other planets?
Yes. Considering what we logically know right now, given that we have no evidence yet of alien life, we have to admit that we could be alone. And yet, just given the sheer number of worlds we know to exist in our galaxy alone and all the possible environments out there, it very much feels like we can't be alone, that there must be something else out there in the cosmos.
To back up, to go forward, so to speak, what is it about Earth? Like, what elements, what conditions did we have that gave ride to us? Like, what? Yeah. Why is Earth Earth, so to speak?
Yeah, well, so I will say first, we don't even know for sure if life started here on Earth. It seems very likely that it did. It seems like life has been here for roughly 4 billion years, given the best evidence we have right now. Because of the plate tectonics and the way that our Earth recycles rock, we don't have any evidence on Earth of the most ancient signs of life. But we really aren't sure where and when life started on Earth, or if there was just one beginning. There might have been multiple attempts at chemistry to become biology, and maybe some of those attempts even merged together at some point and became the life as we know it.
Is that how we kind of think that it started, is the sense that at some point just a bunch of chemicals and minerals just combined and then there it goes?
Yeah, it seems like something happened, some spark occurred where you get into this process of selection for certain kinds of molecules, and chemical reactions can be catalyzed by certain things. And now there's a lot of people out there who are studying what those early things might have been. For instance, some mineral surfaces, so some surfaces of minerals inside of rocks are very reactive and act as catalysts. They can actually catalyze reactions and drive processes forward where organic molecules are forming. Some other molecules that we think can form rather easily in a lot of abiotic or non-living systems, things like some amino acids that can later be put together to make proteins, some things like RNA. We think RNA might have been one of the early precursors to DNA. RNA doesn't just store information the way DNA does. Some RNA molecules can also act as catalysts.
Man, that is my reaction to all of that.
Yeah,
like, man. But how come we can't figure it out? Because it seems like one of those things that, like, okay, we can just backtrack this. Like, what's the hurdle that we can't get over to say, oh, that's where it is?
Yeah, I think myself and many others would say the hurdle is time. We haven't been running these reactions in wet chemistry labs for more than, years, decades at most. We haven't had a large system like the size of the Earth where we can just throw a bunch of stuff together and then wait for millions of years or tens or hundreds of millions of years to see what happens.
How do you look for life on other planets?
There's a lot of ways. I mean, so if it's like Independence Day and like the alien spacecraft comes down into our atmosphere tomorrow, then we can say, yeah, those are aliens. They're here. If we go to Mars and we see like a rock like get up on legs and walk in front of a camera, then sure, that's an alien. But outside of that, it can be really difficult. So if it's not like obvious, like a huge apparent thing, and it's not moving, and it's not making itself apparently some living thing, it could be a little bit more challenging. And so that's where we go into the realm of biosignatures, signs of life, things that life creates that are diagnostic of life being present. The same way that we can look, if you're out, with your children going for a walk in like a park or a forest, and you may look down and see some mud, maybe you see some paw prints or animal tracks in the mud. Those are a biosignature. They're an indicator that there was a living thing present at some point in the past. And if you know enough of your biology, you might even know what the living thing was. Maybe you can tell it was a squirrel or a rabbit or something. We do the same thing looking at the chemistry of life. So trying to look for a barrage of different kinds of things life might leave behind, and mineral signatures, in the way that the rock is changed by life being present and how it makes different layers of rock form together. We can look for things like the presence of amino acids in certain ratios, the presence of certain isotopes of various atoms that are present in the environment. There's a lot of these like diagnostic signatures of life that we can look for on a place like Mars or the atmosphere of Venus or in the ocean of Europa. But then on top of that, there's also another realm called technosignatures. So within this realm of biosignatures, all these different signs of life, there's a smaller realm of the signs of technological activity. And so those are things like SETI, like looking for like listening for messages coming from space that are created by a technological civilization, or looking into an exoplanet's atmosphere to see if there's like industrial gases or like chlorofluorocarbons that we had created on Earth. Like looking for some kind of sign of technology, which could include even maybe one day finding an alien artifact in our solar system or flying into our solar system. There's a lot of possibilities there as well.
Do we have a good definition of what life is?
Not at all. Yeah, we've tried. There's over 300 attempted definitions of life. And one that you'll hear a lot, like online, if you go online and look it up, it's also sometimes called the NASA definition, even though it's never been made official by NASA. It's that life is a self-contained chemical system capable of Darwinian evolution.
But is there any chance that we have found something that would be life if we had a better definition of it?
Yeah, so that's a very interesting kind of realm to think about. So viruses, for instance, some people think viruses aren't alive, that they're just biological machinery. Others think they are alive because our current realm of defining life doesn't include viruses most of the time. Some attempted definitions or trees of life do include viruses, though. There's another realm called the shadow biosphere that some astrobiologists and philosophers have proposed that maybe due to the way that we look for signs of biology on the Earth, maybe there's other forms of life that are part of life as we know it that are here, but they're behaving a little differently, and because of that, we're not seeing them. It seems kind of like far out there to think about, and maybe like a fringe idea, but it is an intriguing idea that maybe there are things alien life could be doing that is happening near us or around us, and we're not seeing it. So like maybe there's some form of messaging or some form of advanced physics that they have where they can communicate through the universe in different ways, and we just don't have the way to see, hear, or perceive that yet.
Is there any kind of debate/controversy in that regard, in that like we found this thing and I think it's life, but you don't think it's life? Is there anything like that where like, well, maybe we did, we're just not defining it correctly?
Yeah, there have been a few examples where something kind of like that has happened. So like the Viking experiments on Mars back in the 1970s, we had these two landers, the Viking landers. They had a series of instruments on board, these biology experiments, and none of them turned up biology. They were very much looking for life as we know it on Mars, things that like photosynthesize, or like us, that take in organic molecules and break them down and make carbon dioxide and breathe that out. They were looking very much for Earth life on Mars. But one of the experiments, called the labeled release experiment, was basically like feeding organic molecules that were labeled with a radioactive element to some of the soil with some water, and then looking to see if anything in the soil was like eating those molecules and then breathing out CO2. And they got a little whiff of what looked like a positive indicator of biology occurring. But the consensus amongst the scientists who've over the decades have reviewed that research over and over again is that it doesn't appear to be a sign of life. It doesn't fit with anything else. None of the other instruments showed any support for it being a sign of life. And so they think it was actually a process of a salt in the soil reacting with some of the organics that we know are there in the process of adding this water. And that was what was releasing the CO2. And so we have a good non-life way for us to have had that sign. But even the guy who ran the experiment, Gil Levin, he passed away a few years ago now. But up until the time he died, he honestly very adamantly believed that he had found life on Mars because of that experiment.
If we do find life on another place, does that mean that life like us is inevitable? Like, okay, we found this here. Eventually, it's going to become us for that place. Or does it not really work like that?
If we find signs of life from another world in our solar system or beyond, then if we find one other sign of life, that alone tells us the universe is probably full of life. It should be everywhere. And if that's possible, and life is everywhere out there, which I personally think it most likely is, I think there's lots of little corners of our universe that are probably inhabited in some manner, then just given the sheer possibility, there should be other worlds that have beings that won't look like us necessarily, but should be similar to us in a variety of ways. And if there are, even 1 million worlds that are inhabited or 1 billion worlds that are inhabited, that alone gives a lot of possibility for a lot of different kinds of life, including other things that are very similar to us.
I don't know if I'll ask this question well, but I hope you'll get the sense of it. To have life like us, I'm thinking of in terms of like you can build a car in a lot of different ways, but ultimately it looks like a car. Would life like us be similar to us? Is there like something fundamental that if you're going to do this thing, you kind of got to do it this way?
There's this process in evolution called convergence or convergent evolution, where there are some forms and functions and patterns and behaviors that life converges back to no matter what. Flight is a good example. So bats evolved flight separate from birds. And so bats and birds did not evolve flight together. Insects that have flight capabilities, and there's lots of those, did not evolve flight in the same pathway either, but flight is converged upon. And so I think we'll very likely, if there are animal-like creatures, we'll find flying ones out there. It's very likely if there are plant-like creatures, we'll find trees out there, alien trees that evolved from different backgrounds but converged.
Are there certain fundamental things that life like us needs? Like, okay, this planet has to have this, 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 this.
So for life as we know it, yes, we have the basic building blocks of life as we know it. The Schnapp's elements, for instance, so carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur are the most common elements in all of the bodies and all the life forms that we have on Earth. But there's also a lot of trace metals and other things. So to form life on a planet, we might need to have planets that are evolved enough that when the star formed, there was enough metal, there was enough other elements besides hydrogen and helium to not only form planets, but also to form planets that had metals at the surface where reaction chemistry could occur. So very early in the universe, the earliest stars that were forming right after the Big Bang would have been composed of solely hydrogen and helium, maybe small amounts of lithium, but mostly hydrogen and helium stars. Then they would go through this process of fusing elements together as they're burning this energy inside of themselves, and that would create heavier elements. But it most likely took some billions of years before we got to the point where we could form Earth-like planets in our universe anyway, because you needed enough of a buildup of metals and other things to make planets like ours. Now, all of that said, in the future, we might be able to alter biology for life as we know it, or even augment life as we know it with artificial life to go out and settle other worlds. And so going to like Mars or Europa or an exoplanet sometime in the future and seeding life there might not mean that we're seeding it with our life. It might mean that we're genetically altering or augmenting the life that we choose to put there to better fit those worlds.
Are you ready for some harder / listener submitted questions?
Love it.
What planet do you look at right now and say, okay, that's our best chance?
Yeah, so people love that question. I think it's actually a really hard one to answer for a few reasons. One, I think the best world beyond the Earth in our solar system to ever have had life was Venus, but only really long ago. So in the modern day, Venus has gone through a lot of geological and atmospheric change. It went through what appears to be like its entire surface melted sometime in the past, maybe 500 million or a billion years ago. Its atmosphere has undergone a runaway greenhouse effect. If it did have oceans, which many of us think it most likely did early on, it lost those oceans. It never had a moon-forming event to form a large moon like ours that would help stabilize its orbit and maybe even help drive plate tectonics. And so Venus underwent a lot of different processes than the Earth, but early on, Venus might have been the best bet. Now, in the modern day, there are worlds like Europa and Enceladus that have these subsurface oceans under their icy crusts that are begging for us as scientists and explorers and people who want to know to go get into those oceans and see if there could be signs of life there. For Enceladus in particular, the water from its ocean is spewing out into space around the moon and forming one of the rings of Saturn, the E-ring of Saturn. And so those could be really great places to look for life. But again, that also depends if life can start in oceans or not. And so right now it seems like Mars, at least in our own solar system, is currently the best candidate. We can land humans there, we can land robots there, we can explore there really easily. We could bring samples back from Mars pretty easily and explore them and look for possible signs of life. Admittedly, for myself, I think if we find any signs of past or present life on Mars, it's going to be very, very deep in the subsurface. So deep that I don't think we've actually gotten that deep, like not deep enough yet to actually look for those samples.
Are we early or late to the party? And I think what they mean by that, like, did we seem to develop our life early, or are we like, no, actually, maybe everybody else is already way past us if there is life in other places?
Yeah, I love that question, and I think we're early. If I had to put money on it, I'd be willing to bet a substantial amount. I bet I'd go on the Long Bets website and bet $10,000 right now that we are very early to the party, because it seems like I said. So in the evolution of the universe, at least in the first couple of billion years, it probably wasn't possible to form any of the kind of life as we know it. So not only to have the elements of carbon, nitrogen, oxygen, that took some time to build up, but to make phosphorus and sulfur and then to start forming enough iron and nickel and molybdenum and all these other things, you need a lot of evolution in stars. You need neutron star mergers and supernova explosions. You need stars to go through billions of years of evolution and then they slough off their outer layers and blow parts of their planets out to space. There's a lot of universal cosmological evolution that probably had to happen to reshuffle all of the elements we needed to start building Earth-like planets, 4.5 billion years ago when our solar system formed. Maybe one thing holding back a lot of life from becoming life like us and having plants and animals and fungi and all these different kinds of modes of operation and stuff like that is that most of the worlds haven't had enough time yet to get there. There have been some really interesting things that have happened to life on Earth over time that have allowed us to form this way, from the creation of our moon to stabilize our orbit, through early evolution to the development of oxygen in our atmosphere because of life. Life altered our planet, which then allowed for life as we know it to come around, to breathe oxygen and use that as an energy source. And so Earth went through a lot of key things that maybe just don't happen as often for some other worlds. There's an idea out there called the rare Earth hypothesis, that maybe some other planets just don't go through enough of the things that we've gone through to actually get to life like us. Personally, I don't really ascribe to that as much. I think we might find out that some of these things aren't necessary. Maybe having a big moon isn't necessary. Maybe having plate tectonics isn't necessary. But it definitely seems like it was helpful for life as we know it.
If alien life does come here, what do you think? What do you think happens to us? Because I think we're dead.
I mean, if it's like an alien virus or pathogen or something that doesn't have intelligence but can feed on life as we know it and is better than life as we know it at competing for resources, it could very quickly just, destroy all of our ecosystems. There'd be great trophic collapses in the food web. Things would shut down pretty quick on our planet in such a case. Like on Earth, for most microbes, if you gave them unlimited resources and let them just grow and reproduce as much as they wanted to, most of them can reproduce so fast they could basically eat the entire Earth in like a day. If they had unlimited resources and access, they don't, because there's competition. But say an alien bug, an alien bacterium or something from space, or an alien organism comes down and rains into our planet and starts eating resources and is much better than we are at competing for them, it could very quickly just destroy all of our life and its own in the process. That said, say it is Independence Day, say like an alien spaceship, a mothership comes down to the Earth. There's two wildly different possible scenarios. One of them is very benevolent and caring. Maybe it could be a first contact scenario, like meeting the Vulcans, and they want to trade knowledge and information. Maybe they want to hear our stories and hear about our culture and our history. And in turn, they're willing to share technology and knowledge with us. That could usher in a whole new evolution for our biosphere. It could be a whole new form of human that comes out of such a process through these new technologies and new ways of being. There's the other side of it, that they could want to destroy us for a variety of reasons. Now, in science fiction, I'll say one thing that I hate in science fiction. It really gets my goat every time. When aliens come to Earth for water, or they're allergic to water, and we've seen both in science fiction now. So aliens who come to Earth for water are stupid, and I'll tell you why. Because there is so much water beyond the Earth in our solar system. Like, Europa has more water in its ocean than all the water we have on Earth. Enceladus is full of water. Pluto is full of water. All of the icy moons of the outer solar system have oceans and oceans and oceans more water than the Earth has. And then if you have a species who's allergic to water, who comes down to our planet and wants to fight us, that's also pretty dumb. They should be wearing like really advanced spacesuits, because there is water everywhere. But one thing that terrifies me when it comes to thinking about what kind of resource aliens might want here on Earth. Since there are all the elements we can think of, the molecules we can think of are out there, except for our chemistry. It might be that maybe our chemistry for life as we know it is a very unique food source, maybe a delicacy for aliens, or maybe consciousness. Maybe there's something about the structures of our neurons and our brains and our intelligence and the kind of consciousness that we have that either seems like a threat or it seems like an interesting food source or a resource for some alien species to harvest. In which case, I'd be terrified.
Yeah, well, that's a new nightmare that I hadn't thought of before
Yeah,
until
you'll sleep on that one tonight, right?
right now. It makes sense though, right? Like anything else that Earth has is available in more abundance throughout the universe except for us. So they
Yeah.
probably would just want us,
Yeah.
which probably isn't very good for us.
It seems pretty awful.
Could alien life already be here? Not in the UFO sense, in the sense that like, what is it, panspermia? Like, is there anything that we think that from life on Earth that like, oh, we're not entirely sure that's from Earth?
Yeah, not at all. There have been some people who've like suggested that octopuses are alien, and they seem bizarre, but they're also, they're beautiful creatures. But there's nothing about an octopus that is alien. Like they have DNA, they have RNA, they have proteins. There is no evidence whatsoever so far that panspermia has happened since the origins of life here and the long-term evolution of life.
I know we're pretty much out of time, but tell me about like kind of what's coming up for next for you. Who's next on the show? That kind of stuff.
Yeah, so I host a show for NASA Astrobiology called Ask an Astrobiologist. It's a lot of fun. I get to talk with really cool researchers. We're trying to get Ada Limon, the National Poet Laureate, on the show to talk about her poem that's going to Europa here soon on the Europa Clipper spacecraft. Nathalie Cabral, I'd love to have on the show. She's a researcher at the SETI Institute. She has a new book out. There's a bunch of great people out there doing incredible research who I want to talk to and ask questions of and have my audience ask questions. And then for myself, I'm transitioning my research a little bit right now more into less of the realm of what is life and how do we look for life on other planets, and more into the realm of what is consciousness and how do we look for other conscious experiences out there in the universe, and can we look for them? Can we understand anything more about it? And does the realm of astrobiology help us to better understand what it means to be human?